The very first video on 3D geometry, we are going to talk about the most basic thing that suppose say you have a point in a space and you're going to join the origin to that point, and then we'll look into the details and certain parts of how we are going to represent that. All right. Now look at this particular figure. Now we have the axis. Let's say you have x, you have y, say you have z, three axes ox, oy, oz. Now, let's assume that you have a point somewhere. Okay, now in this case, what we'll do first, we'll draw a line like this. Say you have a point here. Say this point is A, X, comma Y, comma Z. All right. Now we have a point A, X, Y, Z. Origin is O. Now, to define that line OA in space, we have a certain, rules are there, rules and regulations are there, which you have already learned the basics of this in the last chapter. Okay, that means we are talking about direction cosines. Okay, here again, you are introduced to direction cosines, DCs. What exactly is direction cosine? Now we'll look into it in detail. I know that last chapter you have learnt about this, but then again, since you have OA is a vector or OA is a line in space. Now, when you have a line in space, this line makes three different angles with three different axes. Okay, three different angles. So, in this case, say this makes an angle of alpha with the x-axis, and then say it makes an angle of beta with the y-axis, and gamma with the z-axis. These are the three angles. Now that alpha, beta, gamma plays a very important part in defining the position of that point. Okay, again I'll repeat this, that three angles alpha, beta, gamma, they represent very important point, that is they represent where the point is positioned or situated within the space. Clear? Now that we have the position of the point, now whenever you draw the line, that angle what we are going to get, we are going to define the direction of that particular line from the origin. That means we are going to define direction cosines. Why direction cosine? Why we call it as direction cosine? It's a very important point. Okay, the reason why we call it as direction cosine, here what we'll do, take this OA, okay, O and A. Now, let's say we are going to make this into a triangle. Okay, in the sense, see this? Say this is O, say this is A, this is some point P, where this is alpha. That means P is a point on the x-axis, correct? Now, OA is nothing but R, correct? R is basically whatever the distance we have, the R vector you can call it, modulus of the vector you can call it however you want. OA is R, OP is going to be X, correct? What is cos alpha here? Cos alpha becomes X divided by R. Now this X divided by R, that cos alpha, will represent it as some variable L. So L is called as a direction cosine. So for x-axis, specifically for x-axis, L is the direction cosine. Clear? The next one, same thing if you do it with respect to y-axis. So in this case, what's going to have? Instead of having alpha here, we are going to have beta. And this is going to become y. Correct? So here what are we going to have? Cos beta is equal to y by r is equal to m. Clear? Next same way, cos gamma is equal to z by r, which we can call it as n. Since it's a ratio, we represent that particular direction or the particular cosine as L, M, N. That means here what do we have? We can write that x value is nothing but L into R. Here you cross multiply L into R. Y value is M into R. Z value is N into R. Correct? LR, MR, NR. These are the 3 points, X, Y, and Z. Now what we'll do, we'll square and we'll add. Okay, when you square and add, that means we are doing X square plus Y square plus Z square. What do we get? L square R square. L square R square plus M square R square plus N square R square. X square plus Y square plus Z square is equal to R square into L square plus M square plus N square. But X square plus Y square plus Z square is nothing but R square, isn't it? Because that's a resultant. So R square cancels out. Finally, what do we get? This implies L square plus M square plus N square is equal to 1. This is a very, very, very important relation. L square plus M square plus N square is equal to 1. Clear? Now, this particular relation, you can call it. There's a relation which relates the DCs of all the 3 axes, that is L, M, N of a particular line. Clear? Now, once you have this L square plus M square plus N square is 1, based on this, we are going to discuss in the next video, we are going to discuss about direction ratio and what is it and how we are going to relate this DC and DR. We'll look at this in the next video.